Hello, this is Mr. Henry, and welcome to Lesson 2.2. In this lesson, we are adding and subtracting numbers in scientific notation. Okay, essential question says, how do I add or subtract numbers in scientific notation? Pretty straightforward essential question. Did you know that the width of a human hair is about that big, meters? That can be expressed in quite a few different ways. It'd be this many meters, this many millimeters, this many micrometers, this many nanometers. So your hair is 50 nanometers wide. Okay, these are just some different prefixes that are used to help delineate different size measurements. So micro is small, nano is even smaller. You might have heard of, like, in comic books or cartoons or something, like a nano machine being a super tiny thing. Good. There is no new vocab for this lesson. Awesome. Moving on. So here they'd like us to find the sum or difference of the numbers. Answers should be expressed in scientific notation. Okay. Now, I'm looking at these numbers, and there's a couple things that pop in my head right away. First off is that these have the same exponent. That's good. You want that. If they have the same exponent, then your life is very easy, because essentially the numbers are the same bigness. The exponent is how big or how small they are. Since they're the same bigness, then you could actually just take 5.6 minus 1.2 and kind of treat it like an old school, subtraction problem back in elementary school. I'm going to move this up, and I need more space. Now, yes, technically there's that 10 to the 4th out here and times by 10 to the 4th out here. But when you subtract these, you can really just worry about the decimal pieces. So 5.6 minus 1.2 is 4.4 times by 10 to the 4th power. This does not get subtracted. It's a 4, not a 9. You do not subtract your powers of 10. Okay? So if you have the same power of 10, the same exponent here, all you really have to do is subtract the decimal pieces. I got 4.4 times 10 to the 4th. Now, maybe you don't like that method. Maybe you don't like scientific notation. There's nothing here that says you can't just take this guy. I'm going to put my answer up here just to save it for later. There's nothing that says you can't take this and change them both into standard form. I mean, you could do that. You could say, okay, that's 5.6. I'll move the decimal 1, 2, 3, 4 places. Give me 5, 6 with 1, 2, 3 zeros. And this guy would be 1.2, but I move the decimal 4 places. 1, 2, 3, 4. So he also has 3 zeros. And then subtract them. 0, 0, 0, 4. Oop. I said it. I didn't write it. 4. 4. And then because it says answers should be expressed in scientific notation, then you would take this and change it back into scientific notation. So that'd be 4.4, because the decimal goes between here. And then you'd have to move the decimal from the end to here. 1, 2, 3, 4 places. And look at that. I got the same answer. You tell me which way was a lot less work. I think it was keeping the numbers in scientific notation. Yes, it's a little ugly, and you don't have experience doing it, so it seems a little hard. But look at that. To do it using standard form, that was a ton of work. Doable, but it was a ton of work. Okay? So if the numbers have the same exponent as they do here in letter B, they both have a power of -6, then that makes our life easy. So I'm just going to set this up and down. Now, since it's addition, I don't know. I kind of always like putting the bigger number on the top, sort of thing. But 3.8, I'm not going to, times by 10 to the -6 over 7.1 times by 10 to the -6th. So I'm adding. It's a plus problem, addition. So I'm going to add my decimals, just like I subtracted my decimals in the last problem, because this was a subtraction problem. I subtracted. Here it's an addition. So 8 plus 1 is 9. 7 plus 3 is 10. Times by 10 to the negative 6th. And I have a problem. My answer is not scientific notation. This is 10.9. That is not allowed. So what we have to do is we have to change that into scientific notation. So this is very familiar to what we did in the last lesson. So if you did not do the last lesson, I highly recommend you go back and look. We did like 8, 9 problems like this on how you change something that's close to scientific notation into scientific notation. So here's how we do it, a quick example. So we're going to take this and we move the decimal from where it is to where we want it. So this becomes 1.09 times by 10 to what power? Well, since this number out front here is too big, my exponent needs to get bigger. 1, and since I'm moving it 1 decimal place, it's going to get 1 number bigger. 1 number bigger than negative 6 is negative 5. So if I added these two numbers together, I got 10 to the negative 5th power. Letter C. One for you to try. So if you could please pause the video, try this problem on your own. When you are ready to continue, hit play, and we will go through it together. Okay, so I look at it. We have the same power of 10, which means I'm just going to set them up and down, and then add them up. 2.93 times by 10 to the second power, add them up, add them up, add them up. All right, so, you know, old school addition. I needed something to add the 3 to. It's going to be a 0. So 3 plus 0 is 3. 8 plus 9 is 17. 7 carry the 1. Decimal point. 4.6 plus 1 makes 7 times by 10 to the second power. So we kept our decimals lined up. That's old school addition of decimals. You line up your decimals when you add, and then we just, added up. Added our hundredths, added our tenths, added our whole numbers, and we didn't have to do anything funky because this was scientific notation. It wasn't like a 10 point something or a 0 point something, so we were good. Okay. Again. Letter D. So same dealio. We have the same power of 10 again. So I'm going to subtract. So this is 3.15 times by 10 to the third minus 6.2 times by 10 to the third. Now, I have been doing these all by hand without breaking out the calculator, but there's nothing that says you can't use the calculator. In fact, I'll be honest, I don't really want to subtract this by hand. I could. I don't really want to. Check this out, 3.15 minus 6.2. I'm subtracting just the decimal piece. 3.15 minus 6.2 equals negative 3.05 times by 10 to the third. The power of 10 will stay the same. You're only subtracting the decimal pieces. And there we have it. Okay, if you could please pause the video, try these two. When you are ready to continue, hit play, and we'll go through it together. Okay, so you're taking and you're subtracting. These guys have the same power of 10, so you can just take the 9.3 minus the 5.6. 9.3 minus 5.6 equals 3.7 times by 10 to the negative fourth. And this is scientific notation, so you are done. Letter F. We're adding, same power of 10, so you just add the decimal pieces together. So you're going to take 1.15 plus 9.9 equals 11.05 times 10 to the 8th, and we have a problem. This is not scientific notation. My number out front here is too big. So we need to change it into scientific notation, so it's going to become 1.105. The decimal has to be between the first two numbers, times by 10 to what power? Well, if this number is too big, that means my exponent needs to get bigger. So 8 changes into a 9 because we're getting one place bigger, so it gets one place bigger. Example 2. Adding and subtracting powers with different powers of 10. So if you see here, I have 10 to the 4th and 10 to the 3rd. Now, this is a little bit cumbersome. It's a little bit tricky. There's a couple different ways you can do this. And I'll be honest with you, here, you might find it easier to change everything into standard form. Remember in the last problems, and I showed that one example, it was a pain in the butt to change this one into standard form, change this one into standard form, set them up, subtract them, then change them back into scientific notation. Because when they have the same power of 10, it's like a little shortcut. You just have to worry about the decimals. But when they have a different power of 10, that trick doesn't quite work out. Although, we can make these guys have the same power of 10. That's what this little hint right here is trying to tell us. You can make them so they have the same power of 10. I'll be honest with you, I sometimes find it a little confusing on how I'm changing these powers, and occasionally when I was going through these problems, I made a few mistakes before. So if you want to make sure you don't make mistakes, and if you have the time and you don't mind doing a little extra work, it might be worth it. So this one, I'm going to show both ways on this first problem. So I'm going to first start by changing everything into standard form. So if I change this guy into standard form, I'd move my decimal 1, 2, 3 places. So he becomes 8450 plus, I'm going to move this guy 4 places. 1, 2, 3, 4. So I need to add 3 zeros. 66000. And why not? Let's break out the old calculator. 8450 plus 66000. Just double check, make sure I typed everything in properly. Looks good. And we get 74450. Now, because answers need to be expressed in scientific notation, I need to change this back into scientific notation. So he becomes 7.445 times by 10 to what power? Well, this is a big number, so I'm going to have a positive exponent, and I need to move my decimal 1, 2, 3, 4 places. And there we have it. That is changing numbers into standard form, doing the math, changing back into scientific notation. I would say that's probably none of those steps are hard steps. It's just you have to do a bunch of easy little steps. So if you don't mind doing a bunch of easy little steps, honestly, I'd probably stick with that method. Now, here is the other method. So I'm going to erase this. Actually, how about this? I'm going to hide letter B off to the side here. I'm going to take him, copy, paste. There. That way I can show letter A here as well. So this is the same problem. This is letter A again. But I'm going to show how to make both powers have the same base. So my little hints here is you change the bigger power to match the smaller power. So we're going to make this guy into a power of 3. So this first one's going to stay the same. He's going to be 8.45 times by 10 to the 3rd. Now, to make this have a power of 3, what we need to do is we need to, if we're going to, I'm trying to think of how to say this. This exponent is too big. So we're going to make this exponent smaller. And when we make this exponent smaller, we actually need to make the decimal piece slightly bigger. Here's a way to think about this. So this number here, this is 66,000. That is this number in scientific notation. Okay? Now, we would like it to be to the third power. So if we only move the decimal over 3 places, then this would be 66 times 10 to the third power. See what I'm saying? So if we move the decimal over 4 places, we would get 6.6 times 10 to the 4th in scientific notation. If we only moved it 3 places, we would have 66 times 10 to the third power. So now these both have the same power of 10. So now you can add your exponents, or you can add the decimal pieces together. So this becomes then 8.45 plus 66. So that is the number 74.45 times by 10 to the third. Remember, your power stays the same. And since this is not quite in scientific notation, we are going to add these together. I'm sorry, we're going to, what am I saying? We're going to change this into scientific notation. So we need to move this decimal over 1 place to make this 7.445 times by 10 to what power? Well, this number is too big. Our exponent is going to get bigger by 1 place. So we get 7.445 times 10 to the 4th power. So that's the same problem, once doing it into standard form, once by converting your numbers in scientific notation. I'll be honest with you, I don't find one way be much harder than the other. I kind of prefer this method, changing everything into standard form. It's a lot more steps, I think, but I think the steps are a lot easier. I find this converting here to be confusing most times. There are some times I pick it up pretty easily, but most times I don't think of this very clearly. Given the choice, I'd probably go to standard form almost every time. Letter B. So we want to subtract these two numbers. So more than likely what I'm going to do is I'm going to convert them into standard form, subtract them, and then go back into scientific notation. It's a couple extra steps maybe, but the steps aren't that hard. And actually, now I'm thinking about it, I don't think it's that many more steps. So this number in standard form would be 0. Now I'm going to move the decimal 7 places that way, since this is a negative. So 1, 2, 3, 4, 5, 6, 7, which means I'm going to have 6 zeros. And this guy, I'm going to move the decimal 5 places that way. 1, 2, 3, 4, 5, which means I'm going to have 4 zeros. Notice I'm keeping my decimals lined up here. 1, 2, 3, 4, 2, 9. So those are my numbers in standard form. Now, you have to be careful because if you try to get in the habit of typing all these things in the calculator, you're going to come across some that will not fit. I'm a little cautious on whether that top one will even fit in the calculator. Let me see, 0. What did we say? There was 8 zeros? 6 zeros. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, 3, 1. Okay, it does fit. Minus 0. 1, 2, 3, 4, 2, 9. Okay, that's what it gave me. So I did the subtraction on the calculator. That way I don't mess up with stupid baby subtraction. And we get an answer of negative 0.123 zeros. I saw that much. 2869. Now, we could have subtracted by hand and all that good stuff, but this way is probably a little bit easier. Because I actually technically have these two numbers backwards because this number here is smaller, so this number should be on the bottom. That one's bigger, it should be on the top. So when you subtract it, it works out pretty. That's why we use the calculator. So we can kind of don't have to worry about some of those little rules as much. It's good to know them. Now, this is not scientific notation, so we need to change it back into scientific notation. So I'm going to move my decimal between the 2 and the 8. 2.8 is negative still, times by 10 to what power? Well, how many places am I moving this decimal? 1, 2, 3, 4, 5 places. And since this is a very small number, I get a negative exponent. Okay, here's one for you to try. So if you'd like to try converting everything, making your powers of 10 the same, by all means do that. If you'd like to change everything into standard form to add and subtract, go ahead and do that too. But either way, please try letter C here, pause the video, do it on your own. When you are ready to continue, hit play, and we will go through it together. Okay, so no matter which method you chose, we should get the same answer. I'm going to attempt to phrase the changing of this guy into scientific notation another way. Okay, so I'm going to add these two numbers together, but I want these guys to have the same power of 10. And I'm actually going to make the power of 10 that I want, I'm going to make it the bigger one. So here, I'm going to try to make both of them 10 to the power of 7. So the first one is going to stay the same. He's still 1.5 times 10 to the power of 7. Here, if you think about it, I need to move my decimal one more place this way. Right? Because normally when you're taking, if you have a number, I'm just making pretend, I don't know what this is. That's actually the correct number in standard form. So if you move the decimal 6 places, 1, 2, 3, 4, 5, 6, you get here. To make it to the 7th place, I need to go one more place farther. So this becomes the number 0.7. Now when I add these together, I can actually add that fairly easily in my head. 1.5 plus 0.7 is 2.2. times by 10 to the 7th power. I'm done. That wasn't actually that much work. Now, not the only way to do this. If you did standard form, this would be 1, 5, 1, 2, 3, 4, 5, 6, 7. I'm counting decimal places, not zeros. 1, 2, 3, 4, 5, 6, 7, comma, comma. This is 7 times 10 to the 6, which I just did over here. It's going to be this. And if I add them together, 0, 0, 0, 0, 0, 0, 2, carry the 1, 2, change it back into scientific notations, that become 2.2 times by 10 to what power? 1, 2, 3, 4, 5, 6, 7. Okay? So I got the same answer. Slightly different way of phrasing this, I think maybe makes a little bit more sense in my brain. I need to move the decimal one more place to make this to a 7, so it gets the one more number smaller. Or standard form, whichever works for you. Letter D. Yeah. So we would need to subtract here. So I'm trying to decide if it's worth even doing the scientific notation method. I mean, I suppose we could try. So I'm going to make them both to the 8th power. So this is 3.6 times by 10 to the 8th. To get this other guy to be times by 10 to the 8th, I would have to move the decimal 3 more places that way. 1, 2, 3. So this becomes 0.0028. Now if I'm subtracting this, that still looks kind of ugly. I mean, I'm going to take 3.6 minus 0.0028. And we get what? 3.5972. 3.5972 times by 10 to the 8th power. Now, I'd say the only work that this is kind of saving doing this is it's saving the step of changing it back into scientific notation. Now, if I was going to do this by hand using standard form, this top number would be 3, 6, 1, 2, 3, 4, 5, 6, 7, 8 decimal places. Just commas for prettiness. This one would be 1, 2, 3, 4, 5. I'd have 4 zeros, so I'm just lining up my decimals here at the end. I have 4 zeros, 2, 8. And now when you subtract, you have this number minus this number. If you type that into the calculator, you're probably going to get, well, 35972 36 with what? 7 zeros? 1, 2, 3, 4, 5, 6, 7. Minus 2, 8 with 4 zeros. With that, 35972 with 4 zeros after it. 35972 with 4 zeros. And then you'd have to change it back into scientific notation. So then you have your 3.5972 times by 10 to what power? Well, from where it starts to where you want it, 1, 2, 3, 4, 5, 6, 7, 8 places. You see, we got the same answer. It's the same thing. It just depends on which method you like. Here are, I think, maybe the last two of this type. So go ahead and pause the video. Try these two on your own, whichever method you choose you like best. And when you are ready to continue, hit play, and we'll go through it together. Okay. So letter E. How about this? I'm going to do one of these using standard form, one of these using scientific notation. Okay. That way I'll just kind of show one of each, and no matter which method you chose, we should end up with the same answers in the end. So this first one here, I'm going to do using, I'll do this one using standard form, I suppose. Just giving myself a bit more space. Get Pink Panther out of the way a little bit. There we go. So, scientific note, or I said I was going to do this one using standard form. So I'm going to take this, and I'm going to move the decimal 3 places, making this decimal smaller. So this becomes 0.00743. That's 1, 2, 3 places. Gives me 2 zeros out front. Plus, I'm going to move the decimal 1 place smaller. 0.15. And if I add these together, I can actually see I'm going to get an answer of 0.15743. Don't believe me? You just want to check my work. There we go. And now we change this back into scientific notation, so the decimal needs to go between the first 2 digits, 1.5743, times by 10 to what power? Well, you move the decimal 1 place, and since this is a very, very small number, it needs to be a small exponent. Letter F. If I try to make these both have the same power, I'm going to stick with going to the bigger power. I think I like that. So I'm going to make these both 10 to the 5th power. So the top one stays the same. The first one stays the same. The second one, since this is a 4, I need to move the decimal kind of like one more place this way to make it like 10 to the 5th power. So this becomes then 0.39. And now that they have the same power of 10, I just subtract the decimal pieces. 8.39 8.4 minus 0.39 equals 8.01. Okay. And again, if you did standard form, you should end up with the same exact answer. If you did not, I'd say go back and check your work for mistakes. Maybe you moved the decimal the wrong number of places someplace, or you added instead of subtracted, something along those lines. Example 3. Find the sum or difference of the numbers. Answers should be expressed in scientific notation. Okay, so what this example entails is these are now numbers in different forms. There is some that are in scientific notation and some that are in standard form. So you have to make the decision. Do you want to change them both into scientific notation or change them both into standard form? I would say the majority of students would rather change them into standard form and then answer it and then convert back into scientific notation. That seems to be, from my experience, what most students prefer. Okay, so let's do it. So here, if I change this guy into standard form, I'm going to move the decimal 4 places. 1, 2, 3, 4, which means I'm going to get 2 zeros afterwards. 8, 5, 6 with 2 zeros afterwards. This is 3, 4. I'm just kind of keeping everything lined up. The hardest part about the standard form is making sure your decimals still line up at the end. So 0, 0, 6, 9, 11, comma. And then we change it back into scientific notation. So this becomes 1.196 times by 10 to what power? Well, I'm going to move the decimal from here to here. 1, 2, 3, 4, 5 places. So this is 1.196 times 10 to the 5th power. I changed everything into standard form. I did the math, changed it back into scientific notation. Letter B. I don't know. I'm going to keep going into standard form. I think it's probably the simplest method. Since I already have 19 million here, I'm going to convert this guy. So I'm going to move my decimals 6 places. And since it's a big number, I need to make this big. 1, 2, 3, 4, 5, 6. I'm going to have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. And so I was kind of lining it up with the number above it. So when I do my subtraction right here, I can just kind of subtract. Oh, you can't take 4 away from 0. You got to borrow from the 9. And he becomes a 10. 6, 8 minus 5 is 3, 1. You know, old school subtraction with borrowing. Calculator if you need to, calculator if you can. I mean, I'm not going to say don't use your calculator. I would honestly, if you are going to mess up that subtraction, if you're out of practice doing old school subtraction, I would rather you subtract using your calculator and get the problem right than get the problem wrong. So 136 with 5 zeros. 1, 2, 3, 4, 5, 6 zeros. Right. 1, 9, 1, 2, 3, 4, 5, 6 minus 5, 4, 1, 2, 3, 4, 5. Oh yeah, 5 zeros. Okay. 1, 2, 3, 4, 5. Okay, so yeah, I got it right. And then we change it back into scientific notation. So this becomes then 1.36 times by 10 to what power? Well, from here to here, we're going to go 1, 2, 3, 4, 5, 6, 7 places. Here's one for you to try. Nice little addition. So if you go ahead and pause the video, try this on your own. When you are ready to continue, or if you get a little stuck, hit play and we will go through it together. Okay. So this number here is 1.3 times 10 to the 6th. I'm going to change them into standard form, so I'm going to move the decimal 6 places this way, because that's a big number. So there's 1. And I need to go 5 more times. There's going to be 5 zeros after this. So 1, 2, 3, 4, 5 zeros. And that gives me my 6 places. See? 1, 2, 3, 4, 5, 6. This guy, if I throw my commas in here, helps me line everything up. Because then I know this first comma lines up with here. So I'm going to have 0, 0, 0, comma, 8, 8, 3. And when you're adding up, 0, 0, 0, comma, 3, 8, 8 plus 3 is 11, carry your 1, 2. And now you go back into scientific notation, so this becomes 2.183 times by 10 to what power? Well, decimal starts here, you want it over here, so you go 1, 2, 3, 4, 5, 6 decimal places. And since it's a big number, you get a big positive exponent. You have to have them in the same form to add. My preferred method probably here is standard form. And I think that's probably true for most students as well. Okay, got what? 1 more for me, 2 more for you. So adding. I'm going to go to standard form. So I'm going to take this guy, I'm going to move the decimal 8 places. So I'm going to go 1, and then 7 more times is going to give me 7 zeros after this. So 6, 3, 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, comma, 1, 2, 3, comma. That helps me line up those commas. Because now look, I know that this 53 is going to go right here. Because there's my first comma, 0, 0, 0. And now when you add 0, 0, 0, 3, 5, 0, 0, 3, 6. Just kind of adding across the row. You can throw your commas back in there. And then finally in scientific notation, that would be 6.30053. You need these zeros in between the numbers. You do not need all the extra zeros after the last digit. Okay? Times by 10 to what power? Well, started here, want some here, 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, I think this is the last 2 of this type for you. So if you could, please go ahead and pause the video. When you're ready to continue, hit play, and we will go through it together. Okay, so letter E here. We are going to change this, or I'm going to change this into standard form. If you're doing the scientific notation method, changing them both into scientific notation, good for you. If it's working for you, keep doing it. Don't stop on account of me. But this is the method I prefer, so I'm going to keep doing this method. So I'm going to move my decimal 4 places. 1, 2, 3, 4, which means I'm going to get 3 zeros after this. So 9, 2, 0, 0, 0, comma. And now I know that this is going to line up right here. Since I'm adding, I'm just going to add them up. 7, 6, 8, 2, 9. And then finally, to change into scientific notation, this becomes 9.2867 times by 10 to the power of 1, 2, 3, 4. Okay, lastly here, letter F. So if I go into standard form, I'm going to move my decimal 1 place. So this is just 49.8 minus 18,000. Now if you set this up and down, it would be 49.8 minus 18,000 like that. And you'd have to subtract and borrow, and you're going to get a big negative number. I'm going to go ahead and throw it into the calculator so I don't make any sort of stupid mistake here. Look at that. So this would be a cumbersome subtraction to do. And actually, to do it properly, you would... that's stupid. You would put the bigger number on the top and go through that whole method and make sure your answer is negative. It's kind of cumbersome to subtract it by hand, but it's doable. I mean, I've been doing the addition, so I guess I'll be a good boy and I'll do the subtraction too. So if that's what you're subtracting and that's your negative number, then you can't take the 8 away from 0, so you have to borrow, and you go the borrowing the whole way over here, and he goes down to a 7, and that becomes a 10 down to a 9, a 10 down to a 9, a 10 down to a 9, a 10. And then 10 minus 8 is 2, 9 minus 9 is 0, 9 minus 4 is 5, and 9, and 7, and 1, and E is negative. And see, that's the same thing. So I subtracted by hand. But if in doubt, I'm okay with you checking on the calculator. Now we change this into scientific notation, so the decimal needs to go between the first two digits. So negative 1.79502 times by 10 to what power? Well, the decimal needs to go 1, 2, 3, 4 places. And since this is a big number, and by big I mean there's not a whole bunch of zeros in front of it, you have a positive exponent. Example 4. A standard CD is about 1.2 times 10 to the negative third meters thick. A thin coating on the CD is approximately 7 times 10 to the negative eighth meters thick. How thick is the CD with the coating added? Okay, so we're adding the two things together. So you have a CD. I mean, if I zoom in really far on a CD, there's just the edge of a CD. So you have your CD, and they put a little bit of a coating on the top of it just to make it a little bit thicker. And it wants to know how big is that coating. So we're going to add the two numbers together. So we are going to take 1.2 times by 10 to the negative third plus 7 times by 10 to the negative eighth. I'm going to change them into standard form. Yeah, I'm not going to even attempt to put them both into the same scientific notation or to the same power of 10. So this guy is, I'm going to move the decimal 3 places this way since he's a negative. He needs to be a small number. So that's going to be 0.0012, 1, 2, 3 places, plus I'm going to move the decimal 8 places from here, so 1, and 7 more times is going to be 7 zeros out front. 1, 2, 3, 4, 5, 6, 7. Whoa, 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 whoa. I looked at the 8 from up there. And now when I add these together, I can add them together by lining them up like this. Lining up my decimals. Or possibly throwing them into the calculator. That gives me 0.00120007. And I would imagine you get the same thing if you type it into the calculator. I'm not even going to bother. And then to change this back into scientific notation, which doesn't say it needs it, but it probably should. Then my answer would be 1.20007 times by 10 to what power? Well, 1, 2, 3. And since this does have a whole bunch of zeros in front, it is one of those small numbers that needs a negative exponent. Letter B, one for you to try. Says the approximate area of the continent of Australia is 9 times 10 to the 6th square kilometers. The area of the continent of Antarctica is about 1.3 times 10 to the 7th square kilometers. What is the difference in the areas of the two continents? If you could please, pause the video, try the problem on your own right now, and you are ready to continue, hit play, and we will go through it together. Alright, so a difference is a subtraction. So you're going to take the bigger number minus the smaller number, and in that case, I can tell you that this one is bigger because it has the bigger exponent. See, 10 to the 7th is bigger than 10 to the 6th, so this is the bigger number. Even though the decimal is smaller, this number in standard form is bigger than that one. So you're going to take 1.37 times by 10 to the 7th minus 9 times by 10 to the 6th, and I would probably take them and change them both into standard form because they have different bases. Might be a little bit easier. If you did change them both into scientific notation, it would look like this: 1.37 times by 10 to the 7th, and to make this a 7, you'd move the decimal one more place this way, makes this 0.9. And then when you subtracted this, I don't know, you'd get 7. He goes down to a 0, he goes to a 1. 9 minus 13 is 4. And you change it back into scientific notation, you get 4.7 times by 10 to the, this is too small, so my exponent gets smaller, 6th. Now, if you did it by changing them both into standard form, then this becomes 137 with 1, 2, 5 more zeros. 1, 2, 3, 4, 5, 6, 7. And this guy becomes, well, since the decimal's here, it's just going to be 6 zeros afterwards. 1, 2, 3, 4, 5, 6 zeros. And if we're subtracting, 0, 0, 0, 0, 0, 7, and then that's going to be a 4. And then you change this back into scientific notation, so he becomes 4.7, decimal goes here, times by 10 to what power? Well, the decimal needs to move 1, 2, 3, 4, 5, 6 places. And would you look at that, no matter which method we chose, we got the exact same answer. So it just comes down to personal preference. Letter C. The population of Washington, D.C. is about 5.9 times 10 to the 5th. South Dakota has a population of 8 times 10 to the 5th. What is the sum of the populations? So sum is an addition. So we are adding 5.9 times 10 to the 5th and 8 times 10 to the 5th. I oohed because I didn't line up my decimals properly. There we go. And since these guys both have the same power, it makes my life so easy. I haven't seen one of these in a while. Since they have the same power, I add the decimal pieces. I don't even have to worry about the power of 10. So 5.9 plus 8 is going to be 13.9. Oh, man. I thought this was going to be super easy. Well, we have to take this guy, and since my answer is not scientific notation, we have to make him scientific notation. So we move the decimal, 1.39 times 10 to the what power? This number's too big. My exponent gets bigger by 1 place because I moved the decimal once. And there we go. So that is the sum of the populations of those two places. A blue whale has a mass of about 190,000 kilograms. The mass of a whale shark is approximately 2.6 times 10 to the 4th kilograms. What is the approximate sum of the masses of the blue whale and whale shark? Okay, so try that problem on your own. When you are ready to continue, hit play, and we will go through it together. Alright, so the blue whale has a mass of 190,000 kilograms. And we need to add, the approximate sum, we need to add the mass of this whale shark, which is 2.6 times 10 to the 4th kilograms. Now, I'm going to change this into standard form. So I need to move the decimal 1, 2, 3, 4 places. And if we add these things together, then that gives us 6, 9, 10, 11, carry the 1, that many kilograms. And it's probably a good idea to change our answer back into scientific notation. Since the problem starts in scientific notation, we should end in scientific notation. So we get 2.16 times by 10 to what power? From here to here is 1, 2, 3, 4, 5 places. Example 5, last problem. It says the mass of the white rhinoceros is about 4,850 kilograms, and the mass of a hippopotamus is about 1.4 times 10 to the third kilograms. How much more does a white rhinoceros weigh than a hippopotamus? Answer should be expressed in scientific notation. Okay, so how much more is one of those questions that it doesn't flat out say what it wants you to do, but by now you should understand that that question is a subtraction. If I said how much bigger is something, you would subtract. How much more? How much longer? How much more expensive? All of those questions are subtractions. You're trying to find a difference between two things, and that's a subtraction. Okay? So we need to take the two masses here and subtract them. Now, I'd like to be able to figure out which one's bigger, so I can put the bigger one on the top. But, well, let's just do this. Let's change this guy into standard form. So if I move my decimal 3 places, 1, 2, 3, I get 14000. Oops, that's too far. 1, 2, that's 3 places. And the other one's 4850. And if I subtract them, I can even do it on my calculator. I haven't broken him out in a while. 4850 minus, because I'm putting this guy in first because he's the bigger number, 1400 equals 3450. Okay, so there's my answer in terms of standard form. So already I can say letter B is not right. In fact, I can even say letter A is not right. Look at this. This is not in scientific notation. Answers should be expressed in scientific notation. This is not scientific notation. This is wrong. Letter B was wrong because it had the wrong decimal value. It had to be 3.45. So now I have to decide between these two, which is correct. Okay, so this guy, if I wanted the decimal here, it would be 3.45 times by 10 to what power? Well, 1, 2, 3, letter D is correct. Summary says, what is the most important thing to remember when you're adding numbers that are in scientific notation? So if you had to give one hint to a buddy, a fellow student, on what do you think is the most important thing to do or to remember when you're adding numbers in scientific notation, what would that hint be? You can do the summary on your own. This has been lesson 2.2. Thank you for watching.